Good morning, everybody. Welcome to vlog number 51. Let's build some exoskeletons, shall we? Alrighty, look here. So I'm working on the spine sketch here. So it's coming up like this, coming up the body. One thing that was interesting, I think I ended up putting it a little bit more this way. It's almost a third forward, and I was looking at some x-rays of people, and it seems like your spine runs a little bit more towards the center of your body than I thought. I thought it was a little further out this way. Now this is where the spine is running, but I also believe that that's also where the center of rotation is on these things. Although I think the spine actually kind of, I don't know. It might actually be a little bit more forward than that. I don't know. This is definitely where the center of your spinal column goes. Maybe I should do a little bit more research on actually figuring out how your spine actually moves, because if it moves in here, that's where it should be. But if it's moving, if the center of rotation is on these joints, these are intervertebral joints right here, there's a joint right there. So if they're moving there, I think it's probably moving more. I think the center of rotation is probably more like in the middle of these two. So that might actually want to be brought back just slightly. So, because this is not really supposed to be where your spine is, it's supposed to be where the center of rotation for your spine is. So I'll do a little bit more research on that. What I found, this is actually pretty good. So this is, this paper took it from these guys, White and Punjabi, but this is looking at thoracic vertebrae, and then so you see your axes, instantaneous axes of rotation are there. This is left right, this is extension and flexion, and this is left right movement here. So this is the one we're mostly looking at on this right now. This is for thoracic. This is lower cervical right here, so cervical being up in your head. So still looks like it's more towards the spinal column, I'm assuming there, because that's the bony projection going out there. I guess it's unknown that it's moving inside the spinal column again. So it looks like most of the motion is inside the spinal column, definitely down here. It doesn't explicitly state that these are axes of rotation, but I assume they are. Again, this is a different paper, but they're quoting these guys, White and Punjabi. And it looks like you got that Y plane going right through the middle, and it looks like actually all of them are coming right out of the middle, which is kind of what we want, right through the middle. And this is for lumbar vertebrae, which makes sense. So it looks like I was right, and it is going right through the middle of the spinal column. So that's where the motion tends to be going. So these processes here these must be reinforcing it in some way, almost like the way that my joints work, where the axis is over here, and so the axis can be over here, but the joint is actually moving over here. You know what I'm saying? It's very satisfying to come through here and check these off. That's what the red is. And that's the blue is still what I have to do. Very satisfying, and it's also making me work more efficiently too, for sure. So doing this was a good idea. I wanted to answer a question real quick from Jarmo Teverin on YouTube. I answered in the comments too, and then I thought it'd be more interesting to answer on a video. So he commented, he asked about, he was asking about that. Okay, I actually misread it the first time, but he was asking about the propulsion, and that's kind of what I want to talk about anyway. First time I answered, he asked about the wattage to propel it, and I think he was talking about flying. We started talking about it flying, and he asked about electrically ducted fans. So to answer that, in order to make it fly, electrically ducted fans have high efficiency because they're electric. The problem is going to be they don't produce a whole lot of thrust in a small package, even though they're pretty efficient. So they have high efficiency, but they don't produce a whole lot of thrust. It might be possible to make them produce more thrust if you could find a way to actively cool them. If you could do a superconducting system like that, you could potentially pump more fluid in there, more energy into them, and they'd still be high efficiency. Then the problem becomes powering them with electricity. So you need to do it. You need to have a generator. So this may be something like when we start actually making a reactor that can make the suit more efficient just to blow air. There's also a possibility of electric rocket engines too. And that would be the ultimate goal with flying with the generator. So using a generator would be like electric rockets, and then maybe that could be something auxiliary to that. That's not what I'm gonna do to begin with, because then you have to power them too. So like I could potentially use like an electrical generator, something like one of the jet engines could act as a generator or something like that, or all of them. That might be a possibility, but I still think it'd probably be more efficient just to use jet engines, which is what I'm actually going to use. So what I'm going to use to fly for the first time are RC jet engines. There's a company called JetCat, and they make RC jet engines. And jet engines are nice because you get to capitalize on the fuel, the energy density of fuel, which is a lot higher than the energy density of a battery. And then the ultimate goal would be use the energy density of breaking atomic nuclei, or if we figured out fusion, which would be really dope. That's what it is in the movie, but no one's figured out fusion yet. So I think the odds of me making a small arc reactor to begin with are pretty slim. You never know though. Anyway, so that would be the ultimate goal, is to use the energy density of nuclear fuel. But we're definitely going to start with the energy density of combustion, because that's high energy density, which will make it. We wouldn't be able to fly with electricity, at least not very long. We could make like a prototype, maybe they go, or like a tethered prototype that could run off of mains electricity or something like that, or an external power source, which would be cool too. But it wouldn't be as cool as flying with jet engines, I don't think. So that's the plan. All right, guys, I think this is kind of cool. Look here. So there is the body on, and then that is your axes of rotation for, there's all those lines show the axes of rotation. You can see I decided to put the ones in the hand there, the phalanges. So this is just rotational axes. I mean, and then this is like the spine, but the spine kind of actually looks like that because there's like dozens of, in your real body, there's dozens of axes of rotation. But you see I have 3 here for the lumbar, and then 2 up, or 5 here for the lumbar, 3 up here for that. This is your clavicle, and that comes across to your shoulder. This is in the elbow. This is the hand. So that's how your body kind of moves around. Pretty neat, huh? It's a very visual thing of what everything is moving around. So this is the points that everything is moving around. Very visual in that way. All right, guys, look here. I have the exoskeleton done here. So there is the foot. That's the toes right there. There's your, where your ankle is, that's where the knee center is. This is the transverse plane movement through there. This is just a straight line. I think that's the best way to do it right now. I could potentially kink it, I don't know. But this is what I did to start with. So in here, you'll see that I have all of the first file done. So all the first file on the skeleton there is done. So we got 1 file done. Alright, so now we are officially ahead of schedule, because I remember I scheduled for 1.6 days a file. So that was 1 file, that's 1 file completely done. So we're ahead of schedule for that. I think the 15th I said it was, which is great. Now that being said, that file might be a lot easier than some other files. I suspect that some files will take longer than 1.6 days to complete, probably. Even though I have things pretty well worked out, I'm a little worried about the shoulder still, I haven't done the stand yet. I think some of those may take a little bit longer. We'll see. Maybe it won't, because I do have things better thought out now. And then by doing this sketch here, I have all the axes. I don't have to figure that out, which allows me to focus a little bit better. So it even though you can't take the time directly from what I put on today, because the planning time I did today is going to save even more time. Like so if I put in 20 minutes a day working on something, it's probably going to save like an hour and a half, because I don't have to switch my focus between 2 things. I can just focus on what I need to do when I'm building the future files. So that's cool. So they're just making me more efficient, essentially. That's what efficiency is, right? So by doing that, I've made myself more efficient. So maybe it still will not take as long as I'm thinking for some of those files. I suspect still some of those files will take longer. Oh, and the other thing is I work too. So some of the days when I'm working, I won't be able to get as much done, obviously, as the days like today when I'm not working. But we're looking pretty damn good to start with. Great. Now I had an idea on the wrist joint. The wrist joint is going to have 2 different axes of rotation, and I'm going to do it similar to how I'm planning to do the transverse plane of the sternoclavicular joint. And let me show you what that is. Alright, so this is your hand right here. And so if you look in here, you'll see that there are 2 axes of rotation for your hand to go like this. So 2 axes there. So that's your hand coming back like this, and it's rolling around 2 spots right here. This is obviously not going to be a rotational spot since it's flat, or if it is, it's very, very slight movement. But that's probably just more of a stable joint. And then, there would be your hand going forward like this. So your hand going forward like that around those 2 axes of rotation. So what we're going to do is this right here is dual axes of rotation of the wrist joint right here. So these would be your joints, and then these would be 2 slider joints And that'll be like this right here. So that's the sliding joint on the wrist right there. So these will now be dual, which will make these not have to be as long either, because the rotation will be coming from 2 spots and not just one. So they won't have to move as far. So they'll be about half the size, and there'll be 2 of them like that. But they'll be kind of built onto the same piece like that. So you have one small piece going this way and one small piece going this way, and then this main piece in the middle like this. And that'll give you that really, should give you really smooth motion in there. Alright, I smoked some weed, and I was going to work out and eat, but all I can do is think about what's going on right now. So let me show you guys what I worked on real quick here. So here is just some framing ideas, and it might not look much to you, but it's going to help me figure this out. So this piece right here and this piece right here are part of the part that's coming off of the superficial part, the transverse plane of the sternoclavicular joint, and then this is a plate right here. This is on the superficial part, so this is how I'm going to make like the armor, and then this is all framing coming off of here that's going to connect this all around and make this and then skin, like I'm going to weld the metal, the thin metal in between this like that. So this will be the framing that I skin with metal on top of that like that. So it'll just essentially be kind of like a box that sits on top. It's got enough clearance for these to move around in. So it'll be kind of like some gaps underneath here that this can move in and stuff like that, and then this would be down the side of your body. There might be a little bit of gap for movement just because you can't really put anything there, but this will be kind of a gap in here, and that gap will allow this to go push forward and backwards, forward and backwards. Alright guys, so I have, to quote The Aviator, I had a tiger by the tail here and I'm not letting go. That's a great quote. Anyway, I have an idea I'm working on. This stuff right here, this right here is Ninja Flex. It's a flexible 3D printing filament that I bought a while ago. I think it was for something to do with, yeah, it was for the electrohydraulic exomuscle. I was going to make like a band that went around it. But I have this idea about maybe taking this and instead of using foam, is 3D printing a mesh of this. And see, let's see how flexible it is. It's supposed to be flexible. So it's kind of squishy. I think I might be able to make a like a web of this and then get a squishy material, and then I would use that to make the supports for my body. So there'd be like hard supports coming in to support that, and then the part that's actually touching me, well, the squishy part of this would be, so it'd be squishy and it'd rest up against me, and then I put like a fabric mesh around that in order to keep it from like rubbing right up on my body, and just like let it move and slide a little bit better and kind of protect this a little bit. So it'd be surrounded in like a mesh fabric, like a fabric mesh, and then this would be a 3D printed mesh. And then what I could do is I can vary the infill, the density that it's printed at, and then I can vary how squishy it is. So if it was like 10, 20% infill, it'd be really squishy, but if it was like 80% infill, it'd be like almost a solid piece of rubber. And then what I can do is I can get on spots that are sitting like right on my bones. Those would be like the most important parts for measuring where you are, and you'd also want them to like kind of be up against them with the most stuff, because like if you put one right on top of this one right here, if you put a thing right here, it'd have to be super loose because it's going to be getting compressed by your arm all the time. But if you put one right here, this should actually be like, you could almost make that a solid piece. So that would be like almost like 80-90% of force resting on your sternum of infill on that. So, and then that would be, when you have the sensors, that would be part of what you're sensing. And then probably another one running down your spine or something like that, but your spine kind of gets covered in muscle. But this doesn't really happen here. So this would be like a point, like, so if you're trying to measure where the upper part of the exoskeleton is, so like where you would want to measure like right here, and then maybe some bony parts of your ribs, and then those would be the numbers you try to get the artificial intelligence, the deep neural net. Those are the parts you would try to get that thing to maximize keeping at a certain distance from your body. So those essentially would be what you were trying to get the exoskeleton, or I'm sorry, the artificial intelligence. You would want them to be trying to keep those the same all the time, and then you give them control over the actuation. So like if you lean forward, you push on this, and this would be a very good spot to measure that. The other spots like you could do that would be like around your hips, your hip bones. like on your wrist. So this would be where you want to take really good measurements, and that way that would be part of what the AI is trying to maximize, is parts like right next, like right here. So it'd be one here. So if you push this way, it's going to get more pressure, and so no one knows it needs to move. And then you'd also want it to hold a certain amount of pressure there. So if you started to move this way and the pressure started to come off, the suit would chase it this way, like this. Same thing with here, right? So it would try to hold a certain amount of pressure on your body, and then so like if you push forward into it, the pressure would go up, and it would know, oh, I need to move this way, away from me, and come with it. And then if it starts to pull off of it, it'd be like, oh, he's moving backwards, and follow it that way. And then to a lesser extent, you could try to maximize like parts that are you're less sure of. So parts that would be more likely to get squished. So like if you had a thing right over here, this would be changing a lot because your muscle, your wet mass, is moving around there. But not very much wet mass is moving around that bony part of your elbow right there. Or like, you know, parts, your clavicle for where the shoulders are, that would be perfect right there. The sensor could sit right on there, and then it would move from behind. But that would be like you would sit on your clavicle there. I think this is how I'm going to do it. So I'm going to try, so what I'm going to do right now is I'm going to run an experiment, and I'm going to run a cube of this and a couple of different type of infill patterns and densities and stuff, and I'm going to just kind of play around with it and see if I think it's doable. Problem is this stuff's kind of expensive, so, but fuck it, we're making an Iron Man suit, let's do it right? So we can get this stuff, we can get a roll of it, and we can make it, and as long as we don't use a whole lot of it, I think this will go a long way, especially because we're not doing a lot of the parts of it you want pretty darn squishy. You really only want hard parts where you're going to use a lot of material like right up against the bone. So like, so this would be for the non-power too, is that like a lot of the movement of the thing will be coming on parts that are close to the bone, and then you'll have softer moving stuff kind of auxiliary to that. So let's go ahead and try that test. All right. If you can hear that motor running, that's this motor in here trying to pump the flexible filament through this thing right here, and I think it is not working right now, so I'm going to show you guys what I have to do when that thing is not pumping filament. What to do, which is a pain in the ass, is use this piece right here to grab this thing right here. I have to grab that right there, and then this thing right here that has the hex nut, I have to hold with that. So it's very difficult to do. So, yeah. End up having to use a crescent wrench to get to hold the thing while I pulled this off, instead of this wrench. Okay, so this is the part that actually shoots out squirts out the plastic. And this thing right here is a piece of Teflon. So this is steel. They usually are copper. I replaced mine with steel, so it doesn't abrade as easy if you use something with like carbon in it, which I might use on the composite reinforcement parts. Use something that has carbon fiber in it, so it has more structure or more resistance and compression. Anyway, make it stronger essentially. Anyway, this is the Teflon. It goes in here like this, and it guides the filament into the hot end right here, and it won't burn. This right here, I tried forcing the filament through it, and there's like some kind of carbon composite on the inside, something like burned up, got gunky in there. So I'm thinking the problem is actually this, not this. But I'm going to take this and I'm going to clean it, and then I'm going to try to clean this out too. I think I might have another one of these, but I don't have a lot more, so I'm just going to try to clean this one to start with. You know, hopefully the steel nozzles weren't tempered. I don't think they were, but hopefully they weren't, because if I did, I definitely just killed the temper on this. I mean, I've had to do that before. It's the only way I could get them clean. So I knew I had to take it that hot if this was the problem, but this probably wasn't even the problem. Whatever, they're not that expensive if I fucked them up. Okay, I'm back up in my room, and I got this Teflon piece here, and I think this was what was actually clogging it up, but I just took a drill bit that was like as close as I could find to that inner diameter without being bigger, and just ran it through there a bunch of times and broke up all the carbon composite in there, and then I brought it back up here, and it is fitting the filament now. So I'm gonna put this thing back together and build this shit. This thing is way more jammed up than I thought it was. I'm about to go take apart all of this mess, get in there and try to figure out if I can figure out what's causing it to jam. It's a screw, which is annoying. I have to put this thing back together with one type of screw, but if you look right here, there's a piece of black, goddamn, you can't see it. It's a piece of black filament right there. So I'm gonna rip that thing out and then put this thing back together. Look at it, it's all taken apart right now. The back's all out. That stuff's all out. That stuff's all out. Ugh. And I lost a screw. Jesus Christ. Now I can't find... I dropped another bolt that I can't find. What a poorly designed thing. Alright, I got that thing as fully reassembled as I can, missing 2 bolts. I had a spare of one of them, but one of them I just had to tighten up really quick. Anyway, I'm going to go and we're going to test the Ninja Flex. We're going to see if we can make a flexible thing. A squishy thing. Alright, you can see here I have... This is the part that I'm going to print. Now this is just going to be a test piece, but I actually decided to pull apart just right out of my sketch that I thought looked about right. So that'd be about the thickness I think it should be, about the width, all that jazz. But obviously it would be going down all the way through there, so it'd be going down through all that and that was highlighted right there. But I just did this part because I want to save my material and I just want to see how it works to begin with. So I'm going to print that. Alright, so I took this part because I couldn't get it to print quite right, and I did the meshing myself. So I did this in Fusion 360. Oh, weird. The Fusion 360 is behaving really odd right now with its the way it's looking like this. So I'm going to restart it. I think I need to get a new downloaded version of this because it's not updating anymore through what I have, but I'm afraid Fusion 360 is not going to let me keep my student account if I do that, so I'm a little worried about doing that, so I don't know. But I'm going to go ahead and restart it right now. Hey everyone, it is late. It is it's real late. It's I don't know, 10:30. I've been working since 9:30. I'm fucking tired. I still have to edit video. I started 3D printing these things and I didn't quite work, so I played with the settings, played with the settings. Here's some little squishy things. So I haven't quite figured it out yet. There's a hard part in the middle of this one, which would not be very comfortable. Same thing with this one. There's a little bit of a hard part in there. I mean, it is squishy and I got it to print. This one's a little bit better. This is the first one I did. This one was an octagon. I did 3 full ones and a couple of partial ones, and a bunch of them didn't work. I'm tired. I was hoping to have it a little bit more figured out, so I kept going. I'm like, I'll get it perfect. I don't have it perfect yet. I might have to figure it out. I don't know right now if this is the best option or if I should use foam. I'm too tired to think about it right now. I need to pass out, make this video, post it, pass out, think about it, do it again in the morning. So we'll figure it out. I love you guys. You guys are awesome. You guys have a great night. We'll see you tomorrow. That's it for 51.